Okay, today's presentation will start by reviewing the changes that take place in the human skeleton from the time that we are embryos to the time that we are adults who are finished growing. Our first image here shows the bone of a human embryo, which would be a baby that is in the early development stages within the mother's womb. Notice that in the center of the bone we have a small amount of bone tissue, but most of this is composed of cartilage. Specifically, this is hyaline cartilage, which is useful because it is tough and supportive, but also flexible. And we'll talk later on in the presentation about why it's important that a baby skeleton has those properties. In this diagram, we have a bone that is a little bit more developed. This is the bone of a fetus late in development within the mother's womb, so this would be right before the child is born. And you'll notice that it has a lot more features and details than the bone in the last slide. There is more bone tissue in the center. A medullary cavity has formed where the bone marrow will eventually be located, and the bone has a lot more vascularization, which would be the arteries that bring nutrients to the bone. Additionally, notice that there is bone tissue in each of the ends of the bone, which we have learned is called the epiphysis, and that those bone tissues are pushing out from the center within the hyaline cartilage. So there is still some hyaline cartilage there, but it's being replaced slowly by bone tissue. In this slide, we're looking at a bone of a child. So this is after birth as the child is still growing, and it has even more features than the slide before. Most of this bone is bone tissue. You'll notice that there is some spongy bone, which is the parts of it where it looks like a sponge, and there are small pockets of air in the bone. And it also has some compact bone, mostly in the center of the bone, which we've learned is called the diaphysis. You'll notice that there are arrows in the diagram depicting bone growth widthwise because as the child is growing, the bones are increasing in size to support the child's increase in mass. You'll also notice a more distinct feature between the diaphysis and the epiphysis, or between the middle shaft part of the bone and the rounded end of the bone, called the epiphyseal plate. This is most of what's left of the cartilage that was present in the previous slides, and this is where the growth of the bone stems from. So at that boundary, more bone tissue is being produced, and this will continue as the child continues to grow. This diagram is of an adult long bone, which can be found in the arms and the legs. This is specifically the humerus, which is the top part of the arm. The major difference here between this bone and the child bone on the last slide is what has happened at the place where the epiphyseal plate used to be located. That strip of hyaline cartilage in the child bone has been replaced by a strip of compact bone, and this means that the bone is done growing, and that's why it's considered an adult bone at this point. Doctors sometimes refer to this as the closing of the growth plate. Once that process of going from hyaline cartilage to compact bone takes place, the bone will no longer grow lengthwise, which means that the person is done growing in height. It can still grow widthwise if the person were to gain mass or repair any damage, such as a fracture that would happen from playing sports or being in an accident. The other detail that you can notice here is that the medullary cavity is now filled with yellow fat or bone marrow, which stores nutrients there throughout the adult life. This is an image of the top view of a child's skull, and I want you to notice the gaps in bone tissue at the corner of the plates in the skull. This is another example of where cartilage is still existing in the fetal skeleton and then gets filled in with bone as the child develops. This is an image of the fetal skull with a side view. And again, you can see those gaps between the plates of bone that are filled with cartilage. And we can compare this to the adult skull in the same view on the next slide. And here's that same side view of the skull, but this time we're looking at an adult skeleton. You'll notice that there's no longer any hyaline cartilage showing because it isn't there anymore. The bone plates have fused together and the skull is now composed completely of compact bone tissue. This is a great example of the sort of genius of the skeleton developing the way that it does. If you think about it, as the fetus passes through the birth canal, there's going to be a very small amount of space and there's going to be some pressure on the skull. And this presence of hyaline cartilage through birth is useful because it allows the skull to be compressed without cracking or being damaged. And then as the child's brain grows and develops during early childhood, the skull can grow with the brain by replacing that cartilage with bone tissue.